Alright, so welcome back. So in the previous tutorial, we saw how to work with StructOps to do a simple introduction to StructOps, which is a simple CLI tool or library to build CLIs, right? Let's see how to build and add more features to our CLI that we're building, right? So the name of the CLI is Cipherize, and this is the simple anatomy of a CLI. So we have the command name, right? We have the subcommand, which is this one. We have the optional, so we can be the long format or the short format. So if the long format, we have double dash. If the short format, we have the single dash, and we have the arguments, right? So let's see how to build it. Simple, something like git. So we have git. This is the command name. You have the subcommand, the optional, and then the argument. So I'll go back again to our workspace, which was where we were working on. So in case you want to know the workflow, you can just check the previous tutorial, and I'll clear off all of this, and then we start from scratch. So first, just going to go with use StructOps, and I'm going to import StructOps, and then first we'll just create our simple main function, right? So this is going to be our main function. So fn, then main. So this is the simple workflow, right, of what you'll be doing this show. Now, how do we work with StructOps? As I said, to work with StructOps, all you need is first, in case you don't have StructOps, you can add it to your cargo file. So this is how it is. The name of the package is called StructOps. You can just add it, and then this is going to be the name of the package you're using, the version that you should be picking out from the box. Okay, so first, as I said, it works with the name in the name, which is called struct. So we work with struct, and then we work with enums, right? So we use enums in this case for our subcommand. So let's start building our simple main struct, which is going to be my struct. Then this struct is going to, I'm going to call this struct as a CLI, right? So it's going to be my struct, and I'll give it the name CLI. Then to convert, I'm going to have an attribute, and this attribute is going to be my command enum, right? So I have to create this command enum. So I'm just going to go down here. I'm going to call my enum. This is going to be my command. We have gotten our enum, right, and our subcommand. Perfect. So the idea behind this is that we want to have something like this. So Cipher, this is the subcommand, the optional argument, the option, and then like this. So we have done it in this simple approach here. Now to convert this entire stuff into a CLI, I have to decorate it. So come down here, and I'll be using the macro to decorate this entire stuff. It's going to be this option here, then derive, then I'll pass in my debug, and then my StructOps. So this is going to give this trait to this, right? Then I also need to specify then that this is a CLI, so StructOps. Then I'll give it the name. So this is going to be the name of the CLI. So I'll call it a Cipher, right? Cipherize. And then I can just give it an about. It's going to be the name of the CLI. So a simple CLI for cryptography, right? And ciphers. Something like that. So this is going to give this name to it. Now you see that this is giving us this error here. Command doesn't implement debug, so we need to also add the same stuff to our enum that we have that feature there. Perfect. That is how it works, right? So we have built a simple CLI. Perfect. Now we also need to specify that this is also an optional argument. So I just go back here that we can call, so struct, and then we are decorating it, and then I'll just pass in the subcommand. Because this is a subcommand, I just have to decorate it and tell that this is a subcommand, right? So this is the simple workflow. So this is the subcommand, the main entry point, and this is going to be the subcommand here, right? And then I can now pass in something like this. So let's pass in encode here, and this encode will have some features. So I'll just decorate it again. Struct. Then I'll pass in that, okay, this encode is going to be the name. The name is going to be encode. Then I'll just pass in about, So encode a message using a cipher. Right, perfect. So this is something very basic we have built. Right, now how do we use it? So to use it, I'll just come down to my main file here. I'm going to say let my opt be equal to the, just as we did in the previous one, we just want to specify, I want it to be equal to the main entry point here, which is the CLI. Right, then I need to go with from ax. Perfect. So that is all. Right, I can print it out so that you just see the workflow. Then since this is a collection, I just have to use this particular format, and I'll just go with opt. Then let's close it here. Right, so how does it work? So I'm moving to my CLI apps, to my Cipher. Then to run it, I'll just go with my cargo run -- right, to use a current file. Then I'll just go with the -- help. And now out of the box we have these features there. So we have the encode, which is a subcommand together with the encode a message using a cipher. So this is the encode and this is the message, right? Perfect. It is a subcommand. Then we also, if I get out to here, I can just go encode because it's a subcommand, help, and you see the help information, right? Because we don't have any optional argument here, that's why we don't see anything. But out of the box we get a help info, we get a version info. So I can go back here and I can just go version, and I see the version. So this version here is coming from my cargo file here, right? Perfect. Okay, so you have seen how the simple workflow is, the simple overview is. Now let's add our feature to it, right? So we have encode. So inside the encode, based on what we have here, you want to be able to specify a cipher and a message, right? So to do that, I'll just go back here and I need to add those particular features there, right? So we need to add these options there. So it's going to be my cipher, and this is going to be a string, and then we also need a message, which is also going to be a string, right? So these are the two main stuff. So we have cipher, message, and then string. Perfect, right? That's cool. And then we now want to make sure that we see this. So to make sure we see that, we just have to decode it again. So StructOpt, then I'll pass in the name of it. So StructOpt, then I want to use the short form, so short. So by default it use the first character as the short form, and then the long use a full name there. Then I can also give a help message. So this is going to be the cipher to use. So the cipher to use, we will just give, so example. So we have row 13, and then the one we did was reverse, and then let's say Caesar, right? Right. We can also use Gametra or the rest. We can add them later. Perfect. And now this is now our struct. We can repeat the same for the message. So we have this one here, and for the message, we'll call it as the message to encode. So the message to encode. So this is all that we need. So we have the cipher and then message to encode. Perfect. Because we'll be using Caesar shift, we can also use an optional argument. So this is going to be shift and then shift. If we want to ignore it to make it actually optional, all I have to do is option, then I'll pass in my struct, right? So let's say U8. You can also give it a default value in case you want. So I'll just copy this and decrease this one. So this now is going to be an optional argument. So this is optional, right? so we can ignore it. It's not a must, right? So the user does not need to add it there. So this, I'll call it as the shift value. The shift value for Caesar shift, right? Because not rotating doesn't need this value. That's why we are making it optional. Perfect. That is all. Now let's specify default. You can also specify default. So default is 3, right? Then in case I want to add a default for this, I can actually add it as we saw earlier on, but let's keep it like that. Perfect. So let's see what you have done so far. So I come down here and I run this one here. So everything is working as expected, but we are having some errors. So these are all dead codes, right? But yeah, it works, right? So in case I go back to here, now you see that we have the cipher. This is under the subcommand called encode, which we have, which is this encode here. We have the cipher, which is here, right? So we have the short form and the long form, and then the message to use, which is exactly this message here. We have the message itself, and then the values here, right? Very cool. So that is something wonderful we have done. Now let's also repeat it. We can repeat this entire stuff for the decode, right? So let's do the same. And I'm going to change this one to decode. So we have one for encode and one for decode. Right, so we have decode. Right, so the same idea right behind it. Perfect. That is it, right? So we have, if I go back here, let's check it out. So now we have decode and encode, right? And then both of them work. Now let's add the functionalities to it. So to add the functionalities to it, I just come down here inside my location that I have here. Now I need to add and then pick the right one. So we don't want to be printing anymore. Nada. Right. So I'll now say, okay, let result be equal to match. This is very important. So now we're using match to help us with that, and I'll pick the opt. Then since we have command, now I'll call the command here because we are inheriting this command from here, this particular fee. So if we find it, then we want to now do the matching, the pattern matching. Right, we want to do the pattern matching, and then this is going to be the stuff I want to do. So I want to get the command. We have several of them. So we have the encode, which takes in the cipher message, and then the shift, which is referring to this. So cipher message shift. Perfect, right? And then I'm going to now pipe this one to, so we are matching. If the command is an encode and then it has all the real things that we need, I want to now match it. So match again. Then I'll call it as cipher as string. So we have as mutable string, we have as string, right? And then I'll just check the particular string. So we want to pick this one. And once we are picking that, we want to specify that we want the different rows. So we have row 13 as one. Then I want to match this one to a particular function. So we can have something like row 13. Then I'll pass in the message. Right, so something like this. So this is it. So we have one here. We also need another one for this and this. So we have two, and then this one, and then this one. Right, so I have to, yeah, right. So we have to define this particular function. So we just go to the previous one we did. So remember that we did some time ago. We did some of them, so I'll just go to JCharisTech. I don't need to repeat it. We did it in the previous tutorial, so I just go back here. Everything is here, right? All the things that, if I go back to the algorithms, we had them here inside crypto. We had them there, right? So that's what I'm picking. So we are picking these one. So we have this rotating, Caesar shift and then reverse, right? So let's copy this and then go back here. Outside of this, I want to pass it here, and now I can now use the rotating. So let's go to rotating encrypt, right? So that is there, and then this is also going to be the Caesar shift. So I'll call that Caesar, and I'll call that Caesar encrypt. Right, and the Caesar shift had a shift that we're using, so I'll just go with shift in case there's a shift, and then we have reverse, right? So we have reverse script. Right, perfect. So that is how it works. So the reason we are getting these errors is that we call them at here it takes in a string, right? But we are calling the function is taking slice. So we can now convert it. So you can just use this option here and to automatically pick it out. I'll pass it here. Do the same for this, and then for this. So let's save it, and now it works. Now this is not showing, right? So it expects U8, right? But we have found optional U8. So how do we fix this issue, right? In case it expects U8 and then it has found optional, how do we fix it? So what I'll do is that I'll just go back here. I can change this one. So instead of this, I'll just put in something like this. Then I'll define the shift. So I can just call this let's shift and I'll use it, right? So we are wrapping it and then we are going to use it, right? So now we need to have a wildcard, right, for it. So we have gotten this one here for the rotating, Caesar shift, and then the reverse. Then we need one for the wildcard, right? So that we can also present it out. So that is going to be a wildcard. In case we don't find it, so print line, so unsupported, right? So we have something like unsupported cipher. Perfect. And then let's close it. Expected string found okay, let's take it off. Perfect. So we have gotten it. Now why are we having it? So missing match decode. So we have the encode. We also need another one for the decode. So it's that we have the two. So I just copy the same thing that we had here because we need the two of them. Then I'll pass it here, right? So we have two amps. So this is going to be the decode, right? And then I will just close this one here. Perfect. So that is all that we've done. So the same idea, but we will just show you. So we have the encode, we have rotating, Caesar shift, and then reverse a script. Then for the decode, we can also have rotating encrypt. This is asymmetric, right? So it will still work, right? It's asymmetric to work irrespective of it. So to take, but Caesar shift, we will need a Caesar decrypt, right, to be able to do that. And then this is also going to work the same thing. So this to do decrypt, right? Perfect. So that is how to build a simple CLI. So we have gotten the result, and once we get the result, we will now have to show this result out, right? So in case we have a file we are supposed to send it, we can now show that result out. But if we don't have any file, we just go straight away with this. So let result be this. So we can do this option here, right? Or we can just ignore this because we are not using it, right? And then it automatically picks it out. So in case we have a file that we want to pipe it to, we will just use this option, but we can just take out this one here. And now let's try our code to see if it works. Okay, let's go back. Let's take out Yep, so everything works. I come down here and I'll run it. So we have the help. So it's compiling, everything works as expected. Then I can just go back to encode. We have it here, right? So it's working as expected. So let's try it out. So I want to encode something. So I'll go with the cipher. Let's pass reverse. Then I'll just pass in hello, right? So we need a message. So dash message. That message, and I'll just pass in my message. So hello, it works. So now it's like that's reverse it. So we got it here. It's funny. Reverse. Hello, it works. Right, it was supposed to reverse it, right? But apparently it did not. So let's see where we are making mistakes. We have the message here. We have the string. Okay, it's supposed to show, right? Okay, so yeah, I wanted to show, but this somehow not showing. Okay, hello, it works. Supposed to show this. I think so we get this, we return this. Okay, this particular function doesn't return, just returning a string, but okay. Let's do it this way. So let's, and then outside of this place, once the match has been found, I want to print it, right? So let's go down here. Let's see, right? So I'll go back here, and now it works. So I forgot to return. So we are storing inside result. I forgot to return, and then now we are returning the result here. So you see that now it works, right? Perfect. That is cool. It took some time, and then we can now also add for the reverse. We have rotating. Can do rotating, and now it has changed it. You can also do the Caesar shift, and because we are using the default, if I go with Caesar, it's used the default, right? But I can now specify the shift. Then I can say 14, and it uses the shift key, right? Very cool. So everything is working as expected. I can also do the decode. And it decodes it. Perfect. So that is how to build this simple CLI. So as you can see, it is very useful, very nice to build this, and we get all the information out of it, right? All the information that we need. One thing to notice is that in case you want to add more documentation, right, this here is going to be ignored. But if I go with double like this, it is going to be now seen, right? So this, so this will be shown, right? So the one on top will be ignored, but the one above will be shown. If I go back here, yeah, let's put it in a better way. So this is using the triple here is a way of giving it how do I say it, a documentation. So in case you want to document your CLI, you can also use this particular option here. Perfect. That is something that I wanted to share with you. So now let's see how to add a file, right? So this is okay. Our app works well. We want to add another option in which we can pipe it to a file. to an output file, right? So in case you have an output file, we want to pipe it out, which is also very useful. We can now come down here and add another field. So I'll call this my output file, which this is optional, right? So it's not a mass. Then this is going to be a string that the person can submit. And then I will just decorate this one with one of this. So let's decorate, or assign an attribute, and this is going to be the short form and the long form. So I don't need this. So short. So the short is going to use O, and then the long is going to still stay the same. And then I can specify help message. So help. So I call that output to a tst file, right? To a test file, right? Now that is it. So this, we need to use this one, right? So to use it, I'll just come down here. So we have, since we are now passing a command in an output file, we also need to, the encode stays the same, right? You're not changing anything with the encoding. So the encoding is going to still stay the same. But when we come back to, after you have gotten everything, right? So we have gotten our result here. Once we get the result, we will now want to output it here, right? So this, we are just printing it out. But in case we want to show it out, we can now create some file. So I can just come down here and say something like this. So let mut output be equal to, I can't spell output, right? I want it to be, so if let, let's some file path, if the person give a file path, sorry, is equal to the opt.output file. Then I want to create the file. So I'll be using standard out in the file to create that particular file. So I'll just go down here, and then this will be coming from the standard out package. Else, if there is nothing, you just specify something. Just go with the standard out, right? So we need to import this from Rust. Because we need to be able to write something to the file, and we do that with this option here. So I'll just go to the use. Where am I making a mistake? Okay, let's go back. Yeah, so this here, we need to import file and a standard out from the standard library. So it's going to be here. So use file, use stdfs, and then the file, because we want to use the file, and then use standard out or standard library IO. Then I want to write to a file in case I want to also do standard out, right? Perfect. And then I'll come down here. So we have gotten a standard out here, and we can now show it out, right? Or write to a specified file. Yeah, so the reason is saying that if else it's having some incompatible files that we need to specify that we can write to it, right? So now inside of this boss, instead of file, I want to call write. So dynamic write. So dynamic write means it can accept both the standard out together with the file, right? So it can affect store either the file or the standard out, right? Otherwise it will not work. And then we will now write it out. So let's write it out. So write, there's write line. Now put in the output that I have. Whatever the output I have, result. Then expect something. So let's say code not write to output in case there's an error. Output. So this is a simple way of using it. So we have write line, the output. So writing the output that you are getting, writing the result to the output that you are getting. Right. So let's hide this one. Now let's see. If I go down here, so everything works. Now let's see it out. So we have encode. We have an optional output here, which is very cool. Then in case I want to write any of the code here, so in case I want to write, let's say this, I just go with -- or -o, then example.txt. So it's giving us an error. So the error found argument -o was not expected, right? So I think I have to go back here and then specify it in a full format. It's funny that it's not working. Yeah. Don't worry, we'll fix it. Okay, I see why. We need to close. Wait, we need this to close it. And then okay, yeah, now I understand. So output file example. It can be very interesting, right? Sometimes when you're writing code. Okay, so it's still not working as expected, or I'm not writing the command well. Hopefully I think maybe I'm not writing the command well. Output file. So this is how it's supposed to be, right? Something is missing that I cannot see. Process did not exist successfully. Yeah, okay. So we are spending a lot of time, but this is just the overview. I wanted to add this feature to it, but apparently there is an error, so I will just investigate it, and then you come back and see how to fix it. But that is how to build a simple application. Right now, I can now compile this in case I want to compile it, as we saw earlier on. We can, if I go without the file, let's see if it works. Oh, it works, right? So there's an issue with the file, adding the file support, but it works out of the box. Now to compile this one, to use it, I can just go with cargo build / release, and then this is going to be compiled and stored inside my target directory, which is here. So I go back to my target release version, you see that we have it here, which is quite useful. So I can give it to anybody to use it, and then I can run it. So in case I want to run, I can just move into my target, then the release. You see that we have the Cipherize C. Then I can just write Cipherize SE, not C. Then I can just go with the help. Then it works. So we have all the features there. I can now go with encode. Then I'll just specify the cipher, which is reverse. Then the message. Then I'll call it as thanks for watching. Then we see. It's so funny, right? So that's how it works. So thank you for watching the tutorial. See you another time. Stay blessed. So there, to recap, all that we did was that we just imported StructOps together with the necessary stuff we need, and then we created a main struct which is going to contain our subcommand, and then we created an enum that contains the subcommand together with all the activities we want to do, right? And then we have inside our main function, we are using match to match and then apply the individual functions to it based on what we have. That's the basic understanding. And then finally we wanted to write it here, but apparently it was not working. So let me know in the comment section where I did wrong so that we can fix it together. So thank you for watching. See you another time. Stay blessed.